So now that you've got a functional CA, that's great, but now users/entities have to be able to enroll for certificates. So process involves the entity, we'll call it a user in this case, meets the requirements to submit a request for a particular certificate. Not everybody needs every kind of certificate, so there's a screening process to ensure that all the requirements have been applied. Step 2, that authentication process, essentially that's the RA, that's the registration authority. So there's going to be some policy-based process that determines if you, the entity requesting the certificate, meets the requirements. That's step 3. The policies applied to verify that you do indeed meet the requirements to have that certificate issued. And only then will the certificate request actually be sent to the CA. So there's a utility that you use, this CA, Certificate Authority Utility, that lets you as the admin go in there and take a look at pending requests, and then you can issue or deny. I mean, there's very few options there. You can basically issue the certificate or not issue the certificate. Assume for a moment the certificate got issued. So that's step 5 there. The user/entity is notified, hey, your certificate is available to you. And then you basically, the certificate is a file, that's all it is, with a CER extension to it. And there's a process to install said certificate into the user's machine. And once that process is completed, then that certificate is now essentially ready to represent you out there in polite society. Okay, I think that pretty well covers that. So once that happens, once that certificate is issued, that certificate has a life of its own. The certificate life cycle. Step 1, the CA comes into existence, pop into being. Step 2, once the CA is created using the procedures you guys used in the lab, the user then enrolls for a certificate, and now that certificate exists. So there's a life cycle associated with said certificate. Every certificate, and different certificates have different life cycles. I mean, some certificates may have a 6-month life cycle, some certificates may have a 100-year life cycle, kind of everywhere in between. I'm exaggerating a little bit, but you see the point. Now, a certificate can potentially be renewed. A certificate can expire. That's normal, by the way. Certificates have an expiration date. They expire. They're supposed to. That's normal. Now, there's a couple of situations that may require you to take steps prior to the designated expiration date. If the user leaves the company or the user goes to jail or whatever, changes jobs, whatever it might be, that certificate for whatever reason then is no longer valid, so I would revoke said certificate. There's a couple of techniques we'll talk about in terms of managing that revocation process. Now notice up there, step 3 delta, our little guy up there, certificate is suspended. There's one certificate process, one certificate setting you can select that allows you to effectively revoke the certificate, but you can unrevoke the certificate. Notice how, like for example, let's say you're in the Navy, you're on a nuclear sub crew, and gold crew is out for 6 months. When they come back, blue crew goes out, and then they come back, and then gold crew swaps out with them. So you're going to be on this sub for 6 months, kind of out of contact. So we want to make sure nobody uses your certificate in your absence, so we will suspend your certificate. It's still legitimate, it's just not active. And then when you return, that's the one certificate status that we can unrevoke. Anything else, revocation is a done deal. But if you select certificate hold, then that certificate kind of goes into cryogenic suspension for the time being. Now, another deal. What if somebody maliciously or inadvertently deletes a certificate that should not have been deleted, or revokes a certificate that should not have been revoked? Are you just out of luck? The answer is no. Actually, you can recover the said certificate from a CA backup. So if a certificate got revoked and shouldn't have been, you can recover that certificate from an environment that existed, in a previous backup. So that's kind of an administrative function there, kind of a safety net, if you will. But again, these certificates, they've got basic manageable parameters that you have to deal in, and you'll see that in an upcoming lab as well. So here's a concept. Time for taking on board a concept. I issue you a certificate. It has a long life cycle. Can we recover a root CA if it's down using a private key if we have a backup? Yeah, the question is about the root CA. Can you recover a root CA that was, well, if it's compromised, you're generally you're out of luck. You're going to start over. But mechanically you can recover a certificate that is problematic in some way. If you've got all the parts and pieces necessary to do that, you mechanically can do that. We'll actually cover that in a little more detail coming up. So, hold that thought. So going back to this, let's say I issue a certificate that is good for 10 years. Well, that's not very much administrative effort on my part. I don't have to mess with that certificate for 10 years. But the problem is, the longer the life cycle, the more likely over time it becomes that that certificate and the keying materials and so on could be compromised. Maybe 8 years ago when the certificate was initially issued, it used then a state-of-the-art 64-bit key or some such nonsense. Well, strides in technology kind of have rendered that key strength not very secure, and now my certificate's at risk of being cracked. So a shorter life cycle is more administrative effort, but gives you the opportunity to kind of roll with the technology changes and kind of stay up to speed with current security parameters. So again, the concept, longer life cycle, the longer the certificate's in play, the more likely it becomes over time vulnerable. Whereas the shorter the life cycle, sure, more administrative headache involved there, but you're able to stay on top of security changes more efficiently, more effectively. So again, that's more or less an administrative decision, a organizational policy decision, how you do that. Now, that's not entirely accurate. There's certain situations where you're required by the governance for your organization as to how things, how these processes proceed. All right. And going back to this process, there's a whole list of factors covering certificate life cycle, such as the length of the key. It's again mentioned that basically, the longer the key, obviously the more processing power involved, but the more secure the encryption is. So the goal is to make it secure enough without and basically making it more difficult to crack, by the bad guy than he gets in benefit from doing that. There's different cryptography strengths, cryptography algorithms that can be used. You've got CA physical concerns. Where am I keeping it when it's offline or online? Whatever. Where is it? Who has access to the facility that it's stored in? These kind of factors. Security of the certificates and their private keys. Where are you storing a private key? Is it just in your on your computer in the file system at the default location, or is it stored in a secure, like a safe or something to that effect? Do you have it on your smart cards, your ID cards? There's several certificates on there. Your private keys are on your smart card. So you're pretty much a self-contained cryptography monster with your with all the good stuff that's located in your smart card. Trust issues, administrative involvement, again, the longer the life cycle, the less involvement, the shorter the life cycle, the more involvement, but there are pros and cons with each one. But generally the better choice is a shorter life cycle, so your certificates are more secure just generally overall. So this next bit, let me keep going here. Hang on a second, because the next exercise you're actually going to enroll for a certificate. Now, there's a couple of things going on in this exercise. You may or may not have kind of worked that out yet, but you're going to create effectively a you're essentially running a web server for a fictional college, fictional university, and you're managing the certificates associated with that, and part of that process we're going to show how to secure using SSL, Secure Sockets Layer. We've been talking about it throughout the course, and here's where you actually get the benefit out of that. So to conclude topic B here, let's go ahead and go back into put on our lab coat, and we'll go do exercise 6-3, and that should probably take a good 15 or 20 minutes, I suspect, to get that done. So let's plan here. Let's figure out what we're going to do. Let's do that. It's 2:15. It'll take you another until 2:30. So I'll come back and check with you guys at 2:30. See if you've got that thing finished. If you're finished, great. If you're not finished, let me know, and we'll give you a couple more minutes to get that thing done. So then we'll run through the next section, and then kind of we'll butt the next lab right up against your lunch break, so you can take lunch, do a couple labs, and press on. So go ahead and do exercise 6-3, and then we'll kind of talk about kind of finish up this enrolling certificates section, kind of putting this into play. So I'll be back in 15 to see where you are, and I'll see you then. And we're back. I'm back. How you guys doing? That seems appropriate. All right. Randy, you get a chance to get that done? I'll take that as a yes. All right then. So the policies and procedures that you're running through, did you notice you had to do a little goofy stuff with text files and cutting and pasting and all that old school nonsense? Well, there's a reason for that. We want to make it difficult for that process to be completely automated by some, robot or something. So there's still the human factor element in there. That's what I tell people. I'm not sure that's true. It's possible they just haven't cleaned up their procedures over the years. But yeah, you probably did notice that there was several sort of manual steps involved. Whoop, see it? That would be topic C. Securing network traffic using certificates. Securing network traffic using certificates. Man, that's SSL. That's our secure sockets layer. Just to kind of now that you've got a sort of a better feel, for what the heck a certificate is and what's going on here. Now it makes a little more sense. Now I probably have to. Yeah, I have to fix the definition a little bit here. It's still jacked up even after all these years. Step 1, client requests a session with the server. That'd be the HTTPS server, and generally that takes the form of you, the client, pressing a button that says go to checkout. If you're like buying something, but basically that's the request. That's the step 1. The web server responds by sending you his certificate that he obtained from a third-party provider that you trust. So basically, he sends you his certificate. What's in the certificate? The public key. Okay, once they, now that both of these parties have that, have that certificate in common, the negotiation begins. They negotiate the level of encryption that each one is, kind of willing to support there. So once that's done, step 4, as it reads, once they agree on an encryption level, that much is accurate, the client, that's you, generates a session key. Now, the session key is going to be a symmetric key, like a DES key or an AES key, something like that. And then the definition falls apart. So I'm going to rewrite the actually what I'm going to do. I'm going to go over to the pad here, and I'm going to rewrite step 4 because step 4 is pretty much wrong as is. And let's reiterate. Step 1, request. Oops. Step 2, response. And these are just right out of the book. Don't need to change those at all. Step 3, the negotiation phase. Step 4, okay. Once they agree on an encryption level, the client generates a session key, symmetric, encrypts the data with the session key, then encrypts the session key with the web server's public key. Whoops. Key from the certificate. The encrypted data and the encrypted key are sent to the web server. Okay, that more closely represents what's actually going on there. The definition that they have here is really, woefully incomplete. And then step 5 is, the communication step. That's where, now that both sides have the session key, they can encrypt and decrypt data back and forth during this particular session, hence the name session key. All right, I'll just leave that up there. So that's kind of what's really going on. Again, step 4 is kind of goofed up in the book there. But as long as you understand what's really going on, it doesn't really matter. You can figure it out. Yeah, see, I understand. You can't see the notes. Let me, just for laughs, let me go ahead and select that plain text export option, and then scroll down to where you should be able to see that. But like I say, once you review the video, you'll be able to see what I'm seeing, which should solve that problem. But it's up. You should be able to see my improvements. Right on. Oh, Sam has joined us. Everybody say hi to Sam. Hey, Sam, what's going on? Sam is jealous because I've got this huge class of cool people. He's only got 2 people in his class. But that's okay. What's going on, Sam? I can now.
Yeah, I have to change it to the shouts.
Well, that should work. All right.
All right, enjoy.
Just kind of see it now. Thanks, Roger. That okay. All right, man. Well, we're back in the lesson. Well, I'm not sure what we're doing here. Let's see if I can't regenerate where I was. All right. SSL enrollment process. Okay. Again, and the next lab you're going to do involves actually configuring the web server to be able to participate in SSL. So the web server is going to request a certificate, install a certificate for the purposes of doing this exact process right here. All right.